So we thought about that, and we came up with a strategy wherein can it be possible to provide direct reporting over Hadoop data, right? Obviously, we are talking about some kind of interfacing with that Hadoop data sources that are there, right? And extracting data from there instead of bringing in data in terms of a data warehouse where you need another reporting tool to communicate with that data source. Can it be possible directly use that data that is stored on a Hadoop file system, okay? And then provide reporting or dashboards or ad hoc querying over that data, right? So, and at the same time, can we leverage the computational powers of Hadoop? Like, can we have our own custom map reduce jobs introduced in between, which are executed, transform the data on the Hadoop file system, and finally the output that is there, it can be used for dashboards, reporting, ad hoc querying. You can actually create visual charts out of it, that kind of thing. And overall, like, because the data we are talking about is kind of semi-structured or unstructured, right? So can we provide some kind of structuring mechanism over the Hadoop data itself? We do not have to bring in the data into a structural form in an RDBMS first and then provide reporting over it. Can we do directly it on Hadoop? So that is the idea that we are talking about. The structure, we are talking about a virtual structuring of data rather than a physical structuring of data, because we do not want to bring in that data first, like, because the data can be huge, right? So we don't want to bring it into our system first, hit that bottleneck of performance, and then provide a structure, right? Instead of just create a virtual layer over that data, talk to that data using that virtual layer, and extract meaningful information out of that data. So that is the idea that we are talking about. Right. So now I'll briefly talk about a solution that what we are actually trying to design here is basically we'll create a structural meta layer, a virtual meta layer of objects over the data that is actually stored in Hadoop. Now what we are achieving through that is, obviously I've already discussed that the performance bottleneck is gone, because everything we are talking about is virtual in terms of the layer that we are going to communicate with, and it will provide you with ad hoc transformation capabilities. What I mean to say with ad hoc transformation capabilities is, like, the end user who's actually dealing with that data will have the capabilities of playing around with that data. Okay, I want to see the sales of a particular state. He can just select a criteria at the runtime while he is actually viewing a report or a dashboard, and in a flash, the data will be, the job will be submitted to the Hadoop system, processed, and the data is being returned back. Now the obvious question that comes into mind at this point of time is the performance, right? So obviously, doing it in real-time terms will definitely be done on a smaller data set, right? No one would like to analyze 1,000 million records instantly, right? Even human mind is incomprehensible for that kind of information, right? So if you have to do that, you have to summarize that data in some way or the other. So herein the transformations actually come into picture. You modify the data in such a way that it becomes comprehensible, right? Using these transformations, right? These transformations then can be executed asynchronously, right? You don't have to execute them in a synchronous manner. You can submit these jobs which are actually doing these operations asynchronously using a simple UI, right? You don't have to write a MapReduce implementation for doing all those things, right? You have a custom MapReduce implementation which you can actually plug in, but the front end that is being provided to you is very simple in terms of you just select those MapReduce transformations and execute them. So that is the idea that we are talking about, right? So once you actually perform these transformations, it allows you to visualize that unstructured data in form of a useful information, right? You bring in that data in form of dashboards, charts, crosstabs, matrix, grids, whatever you want, the possible options that any BI reporting solution provides, right? So now what this is the concept that we are calling as visual Hive. Right, now I'll briefly talk about what all we actually did for achieving this kind of behavior and what we are doing to bring it to the next level. Right, so the first and foremost thing was that was required for us to having the capability to talk to the Hadoop file system in such a way that the information is extracted from there in a meaningful way. So the obvious choice that came to our mind was Hive, right? Because Hive provides you with a mechanism of data warehousing interface, right? So you can actually write queries which are executed as MapReduce jobs, right? So we use Hive for doing that. We interface with Hive, we provide Hive as a standard data source as a part of our solution, right? You can connect to a Hive server running in server mode, okay, and you can communicate to that Hive server using JDBC, okay. So for supporting that, the driver that currently Hive provides is very trivial in terms of the implementation, right? So we had to enhance some connection and prepared statement classes for achieving what we actually wanted out of it, okay. We are trying to push these changes as part of the GA so that they are readily available everywhere, okay. Now, as I talked about Hive as we started supporting Hive as a standard data source. So obviously the data that is actually stored on a Hive system has to be presented to the end user in a easier manner to access it and design reports of like queries over it. So we have a query designer which will allow you to perform drag and drop operations. So you can see that here what we have is, this is the connection that I was talking about. You can create a connection out of the Hive server, okay. Then this is the query designer that I was talking about, wherein you can actually select the tables that are present on a Hive server, okay. You can just drag and drop these tables onto the query designer. You can write your queries, you can modify them manually, you can use the designer for doing that, and once you do that, you will be able to create a meta layer out of the system, which can next level usage will be like creating dashboards and reports and ad hoc querying over it, okay. So once this configuration is done, then it provides you with a virtual data layer that you have already created. Now this data layer has the capability of providing you capabilities of transforming the data in whatever way you actually want. Say you want to filter out some data out of this object that you have created. Initially it was just representing a simple file that was coming out of the file system, right? The complete data from that. Now you want to filter it based on certain criteria. So what you can actually do is, you can specify some transformations over that data in terms of filtering, sorting, other transformations like changing the groupings and converting it into a deflate kind of an operation where you actually turn the records in some form of rows, right, which are actually represented as columns, okay. So these kind of transformation capabilities are available, okay. So now these transformations are actually executed as Hive clauses, filtered clauses on Hive system itself. So what we are doing here is, we are allowing you to add filters to the tables that are available. The Hive is converting them into the MapReduce jobs, and those MapReduce jobs are actually being executed on the Hadoop system and bringing in the required data that you want to view, right? So that is where we talk about leveraging the capabilities of Hadoop file system for processing the data, right? Then this business modeling thing is like, it provides you a virtual view of data where you can actually represent your business entities in terms of these objects, and you can play around with these business objects. You can create reports, dashboards on these business entities that are being represented, right? And it provides you with the analytics over this meta layer objects that we are providing, wherein you can create reports, dashboards, chart splits, alerts, already discussed, ad hoc transformations, okay. Right. So that is what we are actually providing at this point of time. Where do we see ourselves moving from here is like we would like to provide a mechanism wherein we have this meta layer component which have the capabilities of taking in custom map reduce jobs written by the end user. You have some like logic of converting the data that is already stored on your Hive clusters, right? So you can actually take in these custom map reduce jobs, submit these jobs using our meta layer to the Hive clusters, which will process that data. Then Hive will actually come into picture and bring out that output that is already prepared out of that conversion. It will provide that data back to our meta layer, which will actually create a virtual data layer over that data, and you can actually create reports and dashboards over that data, processed data, which is being processed by your custom map reduce job. Okay, so that is the idea that where we are trying to go. Next is like we have our own transformations, like I talked about the filtering transformation and all those transformations. We the other transformations we are trying and bringing a library of transformations for our meta layer. So all those transformations, we would like to provide some kind of map reduce implementations for those transformations, which then can be submitted to a Hadoop cluster for execution, and data being processed by Intellicus MapReduce transformations over Hadoop clusters and provide you reporting over that data. It can actually be a series of mapper and reducer implementations. You can actually chain multiple implementations of MapReduce and achieve a transformation over the data that is actually stored on the Hadoop file system. So the idea here is all the processing is being done at the Hadoop cluster, right? Nothing is being brought for processing or reporting into the individual like systems, which can be a normal commodity hardware, right? So we are trying to use the Hadoop capabilities for processing, doing all the processing, so to reduce the data redundancy, time, maintainability problems, of trying to address all those things by using the capability power of Hadoop and Hive, right? So we would like to have a predefined library of MapReduce jobs, wherein you can actually use these libraries for doing those transformations. Maybe if it turns out to be an open source, then everyone can come in and contribute to it, add value to it. These kind of libraries, use these libraries in their own transformations that they require. And then we would like to have a mechanism of providing an monitoring option over the processes that are being executed as MapReduce jobs, right? So it has to be like an asynchronous combination of asynchronous execution of job that you have already submitted, right? And then viewing that or monitoring that job using Intellicus, like what progress it has already made, right? Because running a MapReduce job can actually run into days, right? It's not always possible to get results in minutes, right? So there should be a mechanism wherein you can actually submit those jobs asynchronously and expect results coming out of like in weeks, right? So it has to be an asynchronous mode of execution, and a monitoring system should be there to identify that the jobs are still running, right? It should not be the case like you don't even get to know what you have actually submitted, what's the progress of that. So to overcome that kind of problem, we are trying to bring in these kind of capabilities. Now, the next thing that we are looking forward to do using this complete solution is providing a mechanism of manipulating and integrating and joining structured as well as unstructured data, wherein you have a scenario wherein some of the data is actually present in your RDBMS systems, right? And some of the data is actually present in unstructured form over a Hadoop file system, right? So what we are trying to bring in here is you can pull out data from the Hadoop file system, you can pull out data from the RDBMS data source. You do not need to move that data anywhere for doing operations on that data. So once you have that data, now you apply MapReduce jobs over that data, or transformation capabilities provided by Intellicus over that data and combine that data and then provide reporting or dashboards over that data. So that is what we are trying to do here, right? So I guess we have some time, right, for the presentation.